Hello and welcome to the first edition of the BobCAM for SolidWorks 2D milling webinar. Let's see here. The goal of today's webinar is to gain understanding of the basic workflow of 2D milling with BobCAM V6. As you know, my name is Al DiPaolo. I'm the voice of the BobCAD After Dark video series. You can find me on Instagram at BobCAD-CAM, or you can follow hashtag BobCAD or hashtag BobCAM. So what are we going to talk about today? Well, this is a BobCAM V6 webinar kickoff. It's the basic workflow for 2D milling. We're going to talk about job setup, choosing from the stock types. There's a variety of different stock types that we're going to go through. We're going to talk about toolpath settings, different settings with your toolpath and the effect that it can have. Kind of unlocking some of the secrets of the BobCAM software. And we're also going to look at reporting and simulation, okay, so setup sheets and backplotting, etc. Now, as always with BobCAD, you can expect fewer steps, better cuts, and more profit. Why don't you give me just a moment to set up my screen here, and while we do that, just in the question and answer area, just write down where you're from and what version of BobCAM you're running, if you're running BobCAM, or if you're running some other CAM software. Just a little bit about who you are, where you're from, and what software you're using. That would be great. All right, Jerry looks like he has a question. Jerry, you don't need to raise your hand, but you can just go ahead and use the question area in order to communicate with me. Okay, let's see here. Let me show my screen. Now, here's the thing. I don't know how many of you are on Facebook or not. If you got the invitation today to today's webinar, we do have an exclusive Facebook group for BobCAM. If you haven't joined, I recommend you do so. Let's see, Jerry said wrong button. Very good. We got Steve running version 29, Hughes running version 5. Humberto runs pretty much everything. So again, I appreciate everybody joining us here today. Jerry's from Oklahoma with the BobCAM V6. So I appreciate each and every one of you spending some time with me here today. And again, this is day one of a 3-day kickoff. As you know, my name is Al DiPaolo. I do the BobCAD After Dark webinar series. I do the BobCAD-CAM webinars. If you've gotten a product demo, you may have gotten one from me as well. Okay, so what are we going to talk about? Well, the first thing that I really want to review with the BobCAM software is where everything is. Okay, so to begin with, BobCAM is an add-in for SolidWorks. So you go to your add-ins. Once you've installed the software, you can go to your add-ins, and then you can turn the BobCAM for SolidWorks on. You can either turn it on as you go, or you can turn it on at startup. Okay. Now, when you do turn the BobCAM on, you will notice the CAM tree will be added in the SolidWorks environment. There's also the posting tab, and then there's also the BobArt tab. Okay, so these tabs will be added. The other thing you'll see as well is the BobCAM tab. There are a couple of settings here: settings default, settings part, new CAM job, or launch the editor. And then there's also a toolbar that is created as well, the BobCAM toolbar, which emulates these same settings here, but also has launch simulation and close simulation. Okay. Now, BobCAM does run inside of the SolidWorks environment, and it does pick up on some of your environment settings. So if we go to edit document units and we look at the number of decimal places, the document units will define the decimal places within the software. So it's common to make sure that has at least 4 decimal places. Okay. All right, so we got the CAM tree, we have the posting tab, we have the BobArt, we have the BobCAM tab, we have the BobCAM toolbar. You'll also notice under help, you'll see the BobCAM help, where your license is, activate license, transfer license, use a network license, some of the settings for the network license, BobCAD-CAM support, about BobCAM. We would use about BobCAM. This will tell you the build number that you're running on. I'm running on 2638 for the V6. Okay. Now, unless there's any questions about the environment and where things are located, if there is, just go ahead and ask away. Otherwise, let's go ahead and kind of get into some of our settings here. Okay, so we talked about BobCAM being an add-in, so you can turn it on. We talked about the BobCAM toolbars and where they're located. Really, the next area of the software I want to get into has to do with the structure of the CAM tree. Okay, so this is our CAM tree here. You're going to see CAM defaults up at the top. You can see I have a milling job here. Beneath that milling job, I have a machine. That machine has a post-processor attached to it. Below that, we have our tools. Then we have our stock. You can see we have some setups here. So I have setup 1 and setup 2. Within those setups, I do have some groups. So I have a facing group, a pocketing group, a profile group, and an edge group, edge break group. So these are just different ways you can organize the CAM tree so that it makes it a little easier to see what's going on. Okay. Now, before we get into the milling job, if we go to CAM defaults and we right-click on this, we're going to go to current settings. Within current settings here, this is where you're going to find the different machine parameters. If you're building or editing the machine kinematics, you'll find that there. You can also set the default. You can set the number of tools for the machine, the max spindle speed, rapid feed rate, maximum cutting feed rate. So the machine that you're using, utilizes some of these settings, whether it's for runtime estimates or for link back moves for your adaptive toolpath. So you definitely will want to spend some time in here. You will see the machine definition. Within the machine definition, it will have direction and limits. It will also, if you have machine simulation, it will have your models here and the colors of the different models. And then you'll also have your checking groups down here at the bottom. So when you're checking the tool against the part or the holder, you can use these groups and check them. Items in group number 1 will be collision checked with items in group number 2. So the fixture, stock, table, and workpiece are being checked against the tool. Okay, so you can customize that stuff as well. You have your posting. This is going to be where your NC file extension is, whether you're an absolute or incremental, sequence numbers, turning them on or off, whether there's comments or not, etc. And then you have multi-axis posting. So I'm not going to do a deep dive on this. This is a lot of different settings depending on whether you're running a 4 or 5-axis machine, which isn't really relevant for today because we're looking at 2D machining. Okay, so all right, so we got our CAM defaults in here. When you scroll through this section, there are a couple of areas that I do want to put your attention on. Okay, the number one area that I want to put your attention on is this thread library. Okay, this thread library is used for tapping and thread milling. Okay, you'll see the different groups of threads. So we can go to like a UNC. Within the UNC, you're going to see the thread type, major, pitch, minor, taper angle, and thread angle. Okay, when we tap holes, we use this thread library, and this will call your pre-drill and your tap. So if you're trying to tap a hole and you can't choose the right tap size, it's because you don't have that thread set up in the thread library. Okay, so this is where you go in here and change it. I'll just go to the quarter 20 and I'm going to modify this thread. You have the tap label, major, minor, pitch, thread angle, tapered angle. Now this hole size sometimes is a little confusing. This is the pre-drill hole. So we have a 201 that we're using, and then for a cutting tap, and then if we're a rolling tap, then it's a 270. And you can adjust what these numbers are, and you can add more threads, etc. So that's the first area that I wanted to put some attention on, and that's under CAM defaults. The other area that I wanted to put some attention on is tool pattern. Okay, so BobCAD is a feature-based CAM system, and then if we go in here under 2-axis patterns, you have profile rough and finish, you have pocket rough and finish, you have face, 2D engraving. These, when we're in the wizards, the default configuration of a profile or a pocket, whether it has the rough and finish or not, that is set up here. This is under tool pattern. Okay, the other thing that we're going to want to take a look at here is the material library. Some users use this more than others, but there is a built-in material library for surface footage, chip load. You can go to any one of these materials. There's a few thousand that are included, and you can come in here and you can see your surface footage and chip load that is set up here. You can see it set up for different materials, and then you can also come in and customize it for different types of tools as well. Okay, so I'm just going to touch on that. What I find most is a lot of users just type the speeds and feeds in as they go, or they're going to save and load a feature that has specific speeds and feeds. Now, here's the thing. I'm a BobCAD user. I have been for many years. The SolidWorks drawing environment is a little bit different. Their top view is typically what would be BobCAD's native front view. So, you know, I'm sure their top-down design, I mean, there's different modeling functions that you would utilize here, but one of the things that I find very useful, whether I've imported a file or I've drawn it, is I like the part to be orientated to a top view, or what I would consider a top view. And in SolidWorks, that top view doesn't necessarily match the top view that I'm used to, or this part model. So what I have found that is very useful is you can go normal to the face that you want to be a top view. You can right click here, you can hit this little arrow down, and then you can go set current view to, and you can set it to whatever you want. So for me, I'm going to set it to a top view, and then what that means is now when I go to a front view, I see a front view. When I go to a top view, I see a top view. So that's just a little trick that I think definitely makes a big difference to your overall BobCAM experience. Now, the other thing that I want to get into as well is I want to talk about your tools, okay? Now, you can get into your tools from the CAM defaults. You can go to the tool library. If you don't like the name top, you can change it. Yeah, I agree. You definitely could change it to a different name. To me, Jerry, what I'm talking about is when I hit my space bar in SolidWorks, I get this orientation setup here, right? So this is showing, you know, front, top, bottom, left, right. So when I click on this one here that would represent what I would call the top, I want it to show the part in like I'm the spindle looking down on it. That's why I set it up that way. But I do really like the custom views you can do inside of SolidWorks. So I just wanted to touch on that real quick. But that was another really good point, Jerry, as far as naming them what you would want. Okay, so again, what I'm trying to get into right now is your tool shapes, because, you know, this part here, this is all about 2D. I got some pocketing and profiling and drilling and more than one setup, and we'll go through all that. One of the things that, you know, I find useful as well is if you go to your setup here, you can right-click on this setup, and you can go to blank on blank toolpath. And what blank on blank toolpath does is it will just hide your toolpath. The reason why I find this useful is this way you can isolate and look at just one toolpath at a time instead of looking at all the toolpaths at a time. Okay, so that's another quick tip for you there. But what I want to talk about tool geometry right now. Again, tool geometry is going to come down to, you know, getting into our library. So we'll go to our tools. When we're in our tool library, you're going to see different categories of tools. So you have end mills. This could be for end mill, ball end mill, bull nose, okay? You have rough and finish. These are really two different categories. You could use a rough tool to finish. You could use a finish tool to rough. You could use a rough tool to rough and finish. You could use a finish tool to rough and finish. So it's just two different categories, and when you have a profile rough and profile finish, generally it will pull from the roughing tool for the rough and the finish tool for the finish. But you can mix and match them either way. You do have some chamfer tools here. You have corner rounders, thread mills, single point thread mill, V-tool, taper, T-cutter, dove mill, and lollipop. Now, you're not going to find access to all of these tool types for all the machining features because you're not going to pocket with a single point thread mill. It doesn't make any sense. You're not going to pocket with you know, a T-cutter, for instance. You know, you might profile with a T-cutter. So the tool categories are grouped with what makes sense for the type of machining that you would be doing. Now, if you want an irregular tool or a tool that doesn't match like a standard tool type, like a form cutter, you can create one. I'm just going to click Add here. You'll notice that it does say Assign Tool Geometry, so we can use a sketch to define our tool geometry so we can represent irregular profiles or form cutters, okay? All right, so that's what I wanted to touch on that. The BobCAM does support form cutters. Now, the next thing that I wanted to touch on here has to do with the machining order. So in this case, I have this job set up, and I have a couple of different groups, and within those groups I have a couple of different toolpath features. So the order in which they cut in, you know, how do you control the order, okay? So where you're going to find this is under Milling Job, okay? So you're going to right-click on Milling Job, and then you're going to go to Machining Order. Okay, and with machining order, this is your machining order dialog. This will list out all the feature names, and you have 3 buttons you can press here. These are optimizers. If you optimize by feature, what that does is it puts the machining order in based on the order that the features are in the tree. Okay, if we go individual tool per setup, what this becomes is a tool dominant routine. So once that first tool is called, it will look through the entire CAM tree to find all the instances where that tool was used. Okay, and then you have individual tool. Individual tool is across multiple setups. Individual tool per setup is tool dominant per a single setup. An individual feature would be based off the order in which they are in the CAM tree. So hopefully that makes sense for you. Okay. When we're talking about selection here, we could select a face to machine a pocket or profile. We could also select things like tangencies and loops. The one thing that I feel is maybe different than some of the other CAM packages for SOLIDWORKS is you don't select walls to do profiling. We wouldn't select these walls or multiple walls in order to select what you want to profile. Instead, what we would select would be the edges or multiple edges, and we would do that with a loop or a tangency. Okay? Let's see, Jerry had a question. If you close the part, though it is supposed to delete that order, the order never gets saved. Is it supposed to? Whatever order you have, so let's say we take this and we say machining order and we save it to individual feature, or we save it to tool per setup, and we save that file, whatever the last setting was, that should be how it's saved. If you reorder you know, something, you drop it down in the list or you move it up in the list and you save it, that also should get saved with the file, to the best of my knowledge. And I will test that and we can look at it, but that's how that should be. If you're experiencing otherwise, Jerry, just let me know. We'll take a look at that. All right, so that's a little bit about machining order. We talked about selection. Again, you could select edges, you could select faces, you could select sketches, and you could also select from the feature tree. So you could come into your feature tree and you could select features that you want to work with as well. All right. That is not my experience in movie. Okay. Yeah, we'll take a look at that, Jerry. No problem. All right. How do you default your post processor? Okay. Within the CAM tree, you have a job. Okay. That job has a machine and that machine has a post processor. If we go back to our CAM defaults, we can pick our machine, and then we can also pick our post processor. And then what you can do is you can say save as default right here, and that will default your post processor. Let me see here. So again, under machine parameters, which you're going to get from CAM defaults here, okay? So we're going to go to machine parameters. You can tell which machine you're working on. So this is the BC3X, right? Okay. Let's see. So now if I go to, wish there was a hotkey to switch between this if not. If I go into here to posting and I click select, you can see this is all your post processors that you would have access to. You could select which post you want to work with. Then you can come back to your parameters here and choose Save as Default. And that will save the default moving forward. So every time you create a new file, it will be defaulted to that post-processor. All right, let's see here. Multiple setups. BobCAD does support multiple setups. In this example, you can see I have 2 different setups. One setup here, I'm using the back corner of the part here, and then another setup here, I turn the part around and I'm drilling these holes. So I have 2 different setups that I'm using. With the BobCAM for SolidWorks, you can pick as many different setups as you want. You can use a SolidWorks coordinate system, or you can align the coordinate system yourself. So that is up to you. In order to get to the additional setups, you just right-click on a setup. You go to Additional Functions and then Insert Setup, and that's where you can add another setup in your CAM tree. All right. Now, as far as making copies, okay, we have this part set up here. Let me unblank this toolpath. Okay, I have this part set up here. Now, I might be creating multiples of these parts. There's really 2 ways that you could do this. Like if you're doing a strip of these parts, one way you can do it is to do a toolpath pattern. So we're going to right-click on the machine setup. We're going to go down to Additional Functions. We're going to say Add Toolpath Pattern. There's a couple of patterns that you can choose from. You have an array, translate, rotate, and points. Okay, so an array, you could tell it the distance in X or distance in Y and how many copies, and you could make a group of the same part without having to reselect it and reprogram it. Okay, so basically a toolpath pattern will make a pattern of your toolpath. All right, there is another way to or another way that you may want to create multiple copies. You may want to face this part here, but this part here may be in 54, 55, 56. You may have 3 or 4 different instances of it. Okay, so what you can do is you can copy a feature. So you can copy and you can paste that feature within the tree. Okay, you'll need to reassociate the geometry, so you'll have to select the geometry again. So we'll right-click on this and we'll say Loop and select that again. All of our other settings should carry over from the copy and paste. What we want to change in here is we want to, well, it's going to read the depth, so we need to 0 the depth. But where it says posting here, this is where we're going to want to change our work offset. Okay, so if we've indicated from that back corner there and we want to face the part and it's the same part in 54, 55, 56, we can copy that feature and then we just come in here and we change this work offset number here. So we're going to just bring this arrow down, okay, and then you can choose, 1 is 54, 2 is 55, etc. Okay, so that's another way to make copies of the same part in multiple work offsets. All right, so let's clear that out. Clear. Okay, cool. All right, so that covers that. Now, so that's just kind of a quick run of common questions that I get about the software for all kinds of things. If you guys have any questions about anything that I covered, just go ahead and either raise your hand if you'd like to speak with a microphone, or what you can do is just type in the questions over there in the question box and then we'll hear what you're talking about. Now, so I want to talk about the job setup. Now, I already have a job setup here, which, I have some toolpath on the screen. So there are a couple of things that I want to talk about with that. Okay, so the first thing is hiding your toolpath. Okay, I feel that this is very important because I like to isolate geometry. I like to isolate toolpath, and the easiest way to do this is to blank and unblank your toolpath. So you right-click on your setup or your feature or your group, your setup, your feature, or your group. You go to blank, unblank toolpath, and then what that will do is hide that toolpath, and that's what that red X is. Okay, so the first red X means that toolpath is no longer visible. Okay, if you click on any of the operations, the toolpath operations, that toolpath then will become visible for you. This one isn't because I didn't compute it. As I compute it, you can see it becomes visible. All right, let me get rid of that guy. All right, so this one here, if I click on it, you can see it becomes visible. This is a much easier way to manage what you're seeing, okay? Now, that is the first red X. Okay, the second red X, if you go post yes, no, what that does is it turns off those operations. The reason why I use this is when you're testing out a program, you may not want to post all the operations at one time. You may want to post individual operations. So what you can do is you can turn everything off, and then you can just turn one of these on. So I could turn on just the single facing cycle, okay? So now when I post my code, which I can find under milling job, I'm going to right click on milling job, and then I'm going to go to post, okay? Now I'm just posting just that facing cycle, okay? Versus if I had all of these features turned on. So this is how you can turn on or turn off individual operations, turn on or turn off the visibility. Okay, the visibility is blank on blank. The posting, yes, no, is to turn off the operation itself. So hopefully that makes sense for you guys as well. All right, very good. So what are we looking at here? I have just a really simple part. There isn't anything very sexy about it. I have some open pockets. I have some slots. I have a pocket in the center here. You know, I have a pocket on the other side. So what I've done on this job is I've set up some folders here. The first one is the facing folder. This is a facing cycle here. This facing cycle I have starting at the back corner, and then I have it off the workpiece so you can see it's going past, and I have it using radius link moves as it goes back and forth. Now, in order to visualize the tool following that, what you can do is you can right-click on the facing cycle and choose backplot, and then this will display the tool. So now you can see the tool for any operation in the CAD interface, and then what you can do is you can step through this line by line and see exactly what's going on. Now, Jerry had a question. It would be handy to be able to customize the top to put link icons for posting and simulation. As far as up here, is this where you mean, Jerry? Yes. Yes. Yeah, I agree. It would be nice to be able to add a few more icons in here. A lot of the other CAM programs for SOLIDWORKS have done that. They've used a lot of icons. With the BobCAD system, we've been pretty much this tree structure over here for a long time. I think you'll see as we come closer to releasing BobCAM V6 that some of those things may make it into the software. But really, what makes it into the software, what you want to see added to the software directly comes from your feedback, okay? So I don't know how often you may visit our website. So let me just go to our website real quick here. Give me just a second, guys. Okay, so I'm on their home page now, and if you guys scroll all the way down to the bottom here, okay, all the way down to the bottom, and then there's this section here, bug report feature request. Okay, so if you click on this here, bug report feature request, it's right here. What you can do is you can submit any issues that you may be having with the software, or you could also submit any feature requests, things that you would like to see added in the software. This information goes directly to our development team. It also goes to the Director of Technical Support, and the requests that we get determine the future of the software. So, we really do need your feedback there, and anything that you'd like to see added to the software, make sure you go over there and type it in. And even if it seems silly, it doesn't matter. Whatever it is that you may be interested in seeing the software, that's the place to go. Okay, so we have our facing cycle here. One of them I have on, one of them I have off the material, or I have it off the material, on the material. Then I do single direction on, single direction off. Okay, so these are just showing some of the different settings here. Now, the way that BobCAD works is BobCAD is a feature-based system. And no, that doesn't mean it automatically programs your part. What it means is when you're in your machine setup, you're going to choose from categories of features that you can load: drilling, tapping, counterbore, etc. You have a mill 2-axis here. When you click on mill 2-axis, this is the mill 2-axis wizard. Okay, everything that you need to answer to describe that machining process is done inside of this window. Okay, all the questions that you need to answer. There's an explorer view. There's also a next previous view as well to navigate through this wizard. Okay, so everything that you're going to answer is going to be in here, and the end result, what it creates is a feature. And you can see, you know, like this one here, even if I just finish it, you can see down here it created this feature 2-axis. Okay, now a feature, excuse me, so a feature is associated to geometry. So in other words, you've selected something that goes along with that feature, and then it contains operations being toolpath. Okay. Humberto asked the question, how would I include fixturing like a vise or a clamp? You can bring in, merge any bodies that you want into this file, things like vices and clamps, etc., any work holding, and then as long as those bodies are visible when you launch simulation, they'll be used as part of your workpiece. Okay, so we could add in different bodies into this file to represent our work holding, and that would be used in simulation. So that was a great question, Humberto. Okay, so we got a feature, it's associated to geometry, and it contains operations. Okay, so if we look at this, we're going to come in here, mill 2-axis. Okay, we're going to start this wizard here. We'll select what it is that we want to machine, and then we're going to choose our machining strategy, whether it's a profile, a pocket, facing, engraving, chamfering, or plunge roughing. These are all of your 2-axis machining features. Okay, Jerry had a question. I never tried with assembly. Does BobCAM work with the same in assembly mode? No. At this time, Jerry, BobCAM only works in part mode. It has been requested to work in assembly. I see that's something happening with us in the future, but at this time, it's only in part mode. Okay? All right. Good question. Now, so we have our templates here: profile, pocketing, facing, engraving, chamfering, and plunge rough. Okay, but you'll also notice corner rounding is over here as well. It didn't make it to this main list, but corner rounding is over here as well. Okay, so these are all of your 2-axis machining features or machining operations, and with these, I mean, you can do so much. So let's kind of take a look at it. So we're in facing here. Facing, if we edit this and we go under patterns, you either have a zigzag or a zig. It's either off the workpiece or on the workpiece. Okay, so I mean, again, it's just answering questions. I want zigzag, I want it off the workpiece. This is the distance that I want it off the workpiece by. Which corner do I want it to start in? This corner, this corner, this corner, or this corner? What direction? I want it to run in X. Okay, what's my step over? This is my step over amount. So you just go through and you answer these questions. Really simple. Okay, first, cut offset. Let's take a look at what that one does. Let's erase all. Okay, let's go back to just a normal pen here. Let's cancel out of it. Okay, this one here, if we go to a top view, you can see this green geometry here. This is our tool path. Okay, this is where the tool's going to start. It's going to start over in this corner here, and then it's going to work that way. You'll notice that the first cut, the tool is exactly 50-50 on that line, and generally that's not the best scenario. You get the wobble effect. So how do you handle that? Well, you use this under patterns here, you use this first cut offset, so you can add an amount here, and what it will do is it's going to shift the tool path so that it's not right on the edge of the part there. Okay, so that is what that one does. Now, if you want to change what corner of the face cycle, you can come in here and you could go to parameters, and instead of it starting in the back, you could say start in the front, recompute, and then that's going to update where that face cycle starts from. All right, is there any questions about facing? Any questions before I move on to the next toolpath? If you have any, go ahead and ask away. Otherwise, we're going to move into pocketing. Now, when it comes to pocketing, you have a lot of different types of pockets. Probably the most common is an offset pocket. So right here in the center, you can see we get an offset style pocket. All right. In addition to an offset style, you also get a zigzag. So we have a zigzag style pocket. We also will do an adaptive or a tricordial style pocket. So you have offset, zigzag, adaptive, and then the other kind, using an adaptive, you could do an open pocket routine, where the tool is going to start from the outside. So those are some of the different pocketing routines you have available. When we look at this here, we have some profiling. So we have a standard profile. A standard profile is just going to, walk around the part like what we see here, or walk around whatever profile you give it. So this one's just going around the outside of the part, okay? We also have a ramp style. A ramp style can be used for helical milling. It can be used for a variety of different things, but in this particular case, I'm using it to make a slot. So I have the tool come down, it ramps in, it profiles around, and it comes back out. Okay. If I adjust my ramp amount, this is probably set to, I think, 3 degrees. So if I set this to, 1 degree and I recompute it, then what you'll see is it will take more steps to get down to the bottom. So ramping is good for slots. It's also really good for helical milling. It can be on any shape. On this particular case, I have it ramping on this profile here, but I could even have it ramp on open profiles, etc. All right, so we got our standard profile, our ramp, and then this last one here is called side roughing. Side roughing is essentially where you want the tool to take multiple passes to clean up material. So it works the same as a standard profile. The only difference is you can tell it how much material is left on the wall and how many passes you want to take it in. So that is an example of side roughing for you. Okay, so we have our side roughing. The next thing we're looking at here is our edge break. So edge break, it would be chamfering. You can use a flat bottom or a pointed chamfer tool, and these are going to just come in and break the edges of your part. Okay, so we can do a nice little chamfer routine, no big deal there. Okay, and then the last one I'm showing here, this is the corner round, so we can do a back plot. So I'm using a corner round tool here. This tool is essentially going to come in, and it's just going to put those radius edges on our part right there. So instead of using a ball mill or something like that, we're going to use a corner rounder to come in and to round off those edges. All right, so now that's everything in our first setup. When we get to our second setup, this one here, I'm in this orientation as such, and then I'm really just doing a drilling routine. So this one I'll come in and I'll spot the holes with a spot drill. Okay, so this will come in and spot these holes here, okay, and then I'll come back and drill. Okay, so we'll come back, and I think I do a PEX cycle, so I come in here and I drill these out. All right, so drilling, profiling, pocketing, pretty normal stuff here. Now, let's say you have a pocket routine like I have here. I have this one in the center, and let's say something about this pocket changes, so maybe a dimension changes or something like that, right? So we change this, we check it down, we exit it. All right, so here our design has changed. Now, when we get back into the CAM tree, what's going to happen is it's going to warn you and say, hey, there's been some changes. Do you want to update your geometry for it? Updating your geometry is really just reselecting. That's what update geometry does, is it reselects or reassociates your geometry. So we're going to say yes to that, okay? So when we update our geometry, we update for our change, and then we can come in here and you can see when we click on geometry, the geometry shows in the proper location, but when we click on pocket, the pocket's in the wrong location. So we updated the geometry, but we didn't recompute the toolpath. So to recompute the toolpath, you just right-click and choose Compute Toolpath, and then it will update for the change in geometry. So using this methodology for both 2D and 3D, you can updates for changes that happen in the design. Whether you go back and make changes or not, or a different iteration, or you may have part part configurations, all of which using the same methodology I showed you here is how that would be accomplished. All right, so that is what it looks like with the part already set up. What I'm going to do is delete this setup here. So I'm going to say, okay, delete the job. We have just the part here by itself. So what do we want to do? We want to get in here and start setting up this job. Now, there are other machining cycles that I didn't review. I didn't review rest machining. I haven't gone into any of the 3D machining, but, you know, just to kind of give you an overview of where things are at, I tried to cover some of the more common ones people deal with. Okay, so we got this part set up here. You know, we want to start doing some programming in BobCAD. So what are we going to do? We're going to right click in the CAM tree and we're going to create a new job. Okay. When you're creating a new job, you're choosing the type of job. It's either milling, turning, or mill turn. Okay. BobCAM supports 2 through 5 axis milling, 2-axis turning, and 2 through 5 axis mill turning. Okay. So dual turret, dual spindle, Mazak Integrex style machine. So for today, we're going to choose a milling job, and then we're going to choose our machine. Now, in most scenarios, the BC3X mill, if you're running a vertical machining center, is going to be just fine. If you're running a router, sometimes you have to do some adjustments because you may get inverted or mirrored letters. So you can do this stuff yourself, but generally just use the default machine. You don't need to rename the machine. You don't need to change the machine unless it requires you to do so because your toolpath isn't coming out right. But just by default, the BC3X is a great place to start. Okay, we're going to check this down to start the stock wizard. And we're going to start the stock wizard. Now, the first step in the stock wizard is to select your workpiece. Your workpiece is your part model in simulation, okay? And you can choose to select it or not. Generally, we select the workpiece when we're dealing with mill turn type jobs. In this case, it's not a necessary step, so I'm going to advance past it. And I recommend you do the same. All right, so the next area that we're in here has to do with the stock. So you have rectangular stock, cylindrical stock. You could use a sketch to define your stock. You could use a body, you could use an STL, or you could spin a profile. Okay, so those are your 6 types of stock. The one that most people are going to use is going to be the rectangular stock or the bounding box style. And what that will do is put a box around the minimum maximum of your part geometry. If you scroll down here, it will actually tell you the size of it. So it creates a box, and then what it does is it tells you the size of that box. So if we look at this one, we can see it's a 6 by 4 by 1. Now you can choose enter and then change the size of your stock. That's one way to do it. Another way to adjust for additional material would be to just come down here where it's got these offsets, and you can offset in X, Y, and Z as necessary in order to add stock around the outside of your part. Okay, so that is what we're talking about when it comes to some of the stock settings here. There are cases where your geometry may be what I would say in an in-car position where the geometry doesn't line up with a standard plane, and then you can pick a coordinate system to align the stock to the part, or you could align the stock to the part using this X, Y, and Z axis indicators. That's only if your part is out in space and on some kind of compound curve or something. All right, so those steps wouldn't be necessary here. Really, it's just rectangular. We're going to do a bounding box. Once we get the stock set up here, we can come in and we can add additional offsets as necessary. Okay, once we're done setting up our stock, we can advance. And this is where we're setting our origin or our machine 0, our work offset. This position we're about to pick determines where all the positional moves are based off of. So we're going to snap to this corner here, just like that. We could, if you wanted to have your 0 position based off of a SolidWorks coordinate system, you can do that too. You could say, all right, pick from coordinate system, and then already have drawn a coordinate system and be able to use that. In our case, we actually create a box around the part like this. It's horrible drawing. But we create a box around the part like that, and we lay out these corners for you. Let me erase that. We lay out top, middle, bottom, top, middle, bottom, top, middle, bottom. That way you can just pick these positions as needed. It's all the way through the part. So we put these up there for you to make it really easy to pick. But you could, of course, use a sketch or use a surface edge or anything that's there as well. Okay, so you're not just limited to those positions. You can pick any position that you have on the part. All right, so let's go back to our pen here. We're going to go ahead and really check this down. There's a couple of other things here. Again, you could align your coordinate system to the part just like you could align your stock to the part. Not necessary in this step here. You have your clearance plane. The clearance plane is set on the machine setup. It's not set in the machining feature. So if you want this number to be higher or at a safe plane, you could set what that value is. And then the last thing is what work offset you're in. The work offset 1 would be 54, 55, 56, etc. down the line. All right, and then this last group of numbers here, the XYZ numbers down at the bottom, those are used for machine simulation so that you can move the part around on the machine in simulation. Okay, so that's the purpose of those. For you 2D guys, you probably aren't going to deal with that too much. You're going to just pick your 0 position, check it down, and we're good to go. Right now we have a job. We have a job that is connected with a machine that has a post-processor. We get in here to our tools. We could start loading tools in from the tool library. We could come in here to the tool crib and load a tool from the tool crib to preload tools, or you can just call tools as you go. No big deal. All right. I do want to bring something up real quick. Verify tool assignment under milling tools, verify tool assignment. This will list out all the tools that are in the job, and you can renumber your tools right from there. Okay, so that's a very useful feature. Usually a sanity check before you post. You just want to make sure your tool numbers and the tools that are using are correct. All right, so we have our job, our machine, our post processors. We got our tools, we got our stock, and we got our setup location. All right. Is there any questions about where I'm at right now? Anything at all? If you have a question and you'd like to ask it, just go ahead and raise your hand, and I'd be more than willing to answer any questions that you have. How to edit a tool that is being used. Jerry, you can't edit a tool that is being used, and I'm not sure exactly why. I mean, it does make sense. What I generally will do there, Jerry, is I will pick a different tool, and then I will go to a new file and edit the tool from the tool library there. And then once I've edited that tool, then I'll go back and pick it. I kind of have to do a little bit of a dance, but that is a good point, being able to edit a tool that is currently being used. Sounds like a good feature request. I'd probably put that in. All right, so milling job, machine, post, tools, setup. Now, let's go ahead and look at doing a facing cycle here. So we're going to right-click on the machine setup. We're going to go to Mill to Axis. Okay. When it comes to geometry, I'm going to go to Select Geometry. I'm going to move my mouse over the bottom of the part. I'm going to right-click. Okay. I'm going to choose Loop. I'll click the arrow to set the direction of the loop, and then I will check it down. All right. Now the problem by doing it this way, I'm picking up the bottom of the part, so it's going to actually measure that. So when we go to our feature depth here, you can see it's set to 1. Because I just want to face the part off, it's a common practice for me to set the face to 0. That way they can adjust out at the control. So we'll face to 0. We're going to go ahead and choose Next. This is where we're going to choose our operation. So we're going to come in here to facing, and then we'll choose Next. Tabs, there's no tabs in this example. Tabs would be to hold, to leave material between the stock and the part so that the part doesn't break free. Real common with like sign makers and letters and smaller parts and unique fixturing scenarios. But no tabs for this one here. Posting. Not much to do there. Really, I just want to jump ahead to the tool. I'm going to just type in 2 inch, so I want to use a 2-inch face mill. By typing in 2-inch, it will go to the library and find a 2-inch face mill for me. So that's an easy way to do it. If a 2-inch face mill didn't exist, it would create one for me. So it's really easy to enter tools and get going and get moving, you know. All right, so you got your tools set up. Okay, you got your patterns. You have zig, zigzag. So we're going to do, let's say, single direction. We'll say off the workpiece, starting in this corner. We'll give it a first cut bump. And then the only other thing I want to edit here is maybe links with a radius and compute. Okay, so now I have my facing cycle done. All right, I'll visually check it by right-clicking on the operation and going to a back plot, and then I can see that it is facing. All right, looks good. Now, so I've done a face cycle. Now that that face cycle is there, I'm generally going to blank it out, so I'm not looking at it. And then I can start addressing some of these other areas. Okay, so if I wanted to cut this pocket or cut this profile, but I'm going to go straight to the open pocket because this is a really cool feature. Open pockets is where the tool, you want the tool to start from the outside. And with the BobCAM, you can come in here, mill to axis, select geometry. We could pick this face and this face. Those are the two areas that I want to pocket. I'm going to check them down. All right. Machining strategy, pocketing. I'm going to remove the finish pass. I'll go to my tool size. It's going to be a 1/2 inch end mill. I'm going to do an adaptive pocket. We'll do a 25% step over. And then compute. And the cool thing is with BobCAM is it's gonna know that that boundary intersects with the stock geometry. So that tells that it's open, and it will just machine from the outside, okay? So I haven't launched simulation. Let me go ahead and open simulation up. John has a question. When it does the update geometry, does it do it for the entire CAM tree or just a single change feature? If it's the former, sometimes it plays havoc with drill depths or drill diameters when I'm drilling slightly oversized CAD geometry for express tap. Okay, so John, let's get back to you in just a second on that. All right. So again, I'm in simulation. Simulation is very advanced. Has a lot of different options. It uses a ribbon bar, so it's very easy to see what's going on. And again, I'm just demonstrating this is that open pocket where it comes in from the outside. Okay. Now, John had a question about update geometry. If you go up to the top, if you go to the milling job, and you choose update all geometries, then that updates everything in the CAM tree, okay? If you go to a feature and you say update all geometries, that updates just that feature geometry. And if you were in the CAD window here, let me see, and then I edit one of these features here. So we'll make this bigger. Okay. When I get back into the CAD tree, the model geometry has been modified. Some of the machining features may longer be valid. Do you want to auto-update the CAM tree? I believe that this just reassociates the feature that changed. I believe that to be true, but I'll definitely check that. Now, you bring up a really good point, John. You talk about drilling slightly oversized when you're doing tapping. You may have missed the first part of this webinar, which is when you're tapping, right? So if I do a tap cycle, the tap is actually based off this thread type. It's not based off of a SolidWorks hole library. It would read the hole size, but it will actually override that for your pre-drill hole based off of the tap that you select from the thread library. And then within the thread library, if we go to the thread library and then the UNC, we'll go to the 1/4-20, right? So you can see this is the hole size, the pre-drill hole size for a cutting tap or a rolling tap. And you can see there are two different numbers. And you can set what those numbers are. When you call that 1/4-20, it's going to call that 201 for you. So that's how you handle that. Now, as far as the auto update for the entire model. If you auto update the entire model and you have drills that maybe you've changed some of the depths, one of the things that you can do when drilling, if you go to drill and then you select something, let's go to like one of these. Okay, there's going to be used cutting conditions. Once you've set up that hole, if you uncheck use cutting conditions, the havoc that's happening with your drills when you're doing updates should go away. So I would try unchecking this use cutting conditions, and I think you'll be in a good spot. But another really good question. Okay, so we did our open pocketing. I did my change for my open pocket. You know, I made the radius bigger in the corners. I'm just going to recompute so that the toolpath will be updated for the change. Okay, so now the toolpath is updated. All right. Let's say we want to do this pocket feature here. We're going to come in, mill to axis, select geometry. We're going to pick this space here. We'll check it down. We'll go to our strategy, pocket. Again, I'm just going to remove the finish pass. We can set what our tool size is. Okay, we can come in. Is it a zigzag pocket? Is it an offset pocket? Offset in, offset out. So we'll do a zigzag. I'll just compute the defaults here, and there you can see we have a pocketing toolpath. Okay. Now, if I come in here, let's say I want to profile really any geometry that you want to profile, you just have to select the edges or the loop that you want to follow. You could pick a sketch or something like that. Let's look at maybe putting these, using the corner rounder to break these edges here, right? So how might we do that? Well, what we're going to do is mill to axis, select geometry. I'm going to select the bottoms of these, this one here, this one here. I'm going to check that down. I'll go to my machining strategy. This time I'm going to remove both those operations and just throw the corner round over there. From there I can set my tool information. This one, for some reason, the shaft diameters, they always have really small. So we'll just thicken that up a little bit. Maybe add some leads here. So we'll do parallel and compute, you know, and then now you can see this one's going to come over and do this corner round. So it's going to come in and get that side and come in and get that side. All right, so, you know, profiling, pocketing, pretty straightforward there. If we want to tip this up on its side here, we can tip it up on its side just like this. Turn it around in the orientation that we want. We want to get another setup going on here. So what we'll do is we'll go down to where it says add additional functions. We're going to say insert setup. We'll go ahead and edit our setup location. It's got the original location, so what we're going to do is put it back on this corner here, and then now we need to align this corner so that our X and Y are going in the proper direction. So we're going to say X direction will invert, and then Y axis will be this way, and there we go. We have X, Y, and Z pointing in the proper direction. We could change the work offset number. This could be work offset number 2. We'll check it down. All right, so now we have our 0 where we want it to be, so then we can come in and start doing our drilling. So we'll say drill hole, select geometry. Now I could just select the tops of these, but then it's not going to pick up the depths for me. Okay, so sometimes you may want to do that. You know, I could select the cylinders here, and then that way it's going to pick up the depths as well. So we'll say those. We're going to go ahead and click through here. We're going to set our strategy, hole, compute, you know, and this is going to go through and spot and then drill that. Now, let's say we were going to tap those holes, right? Let's see. Humberto has a question. In the CAM tree, does not show the type of material to be machined. In the CAM tree does not show the type of material to be machined. It does show the type of material. If you come over here under stock, this is where your material is set, okay? The material doesn't match what the part may have been modeled at. It's going to be based off of your stock. This one's set to 1018 carbon steel. We can edit this and go to aluminum or carbon steel or copper, whatever we want to do. I'm going to go to aluminum, maybe 6061, something which is pretty common. to use. So that way you can tell it what material you're using. When you tell it what material you're using, it's also going to load surface footage and chip load to calculate speeds and feeds. But most of the time people are saving features. So you can go to a feature and you can save that feature. So that way you can save depth of cut, width of cut, stock for finish, speeds and feeds and things like that. Okay, but great question, Humberto. Okay, I could not visualize that. Thanks. Okay, cool. Yeah, your material is right over here. This way you can see where the material is. Okay, now, so we did this, we drilled and tapped on this section over here. Now what happens when you have two different setups within the simulation? Like what happens in simulation when you have 2 or 3 different part flips or whatever the case might be? The software will just pick up where the flip is. So, you know, we can go next stop. Let me turn the toolpath off. So we can go next stop, so that one does that. We go next stop, that one does that. We go next one, that one does that. You know, and then it just switches over to the next orientation. Okay, so you don't have to keep track of the stock or anything like that. You can see how the part will be processed fully just by running it through a simulation. All right, very good. So, but I wanted to jump back into this the tapping. So this is a 3/8 hole, right? So what if we wanted to tap that with a 1/4-20, you know, instead of it being a 3/8? Well, we can go to tap hole, select geometry. We can pick these 2 cylindrical faces again, all right? But instead of it picking up this hole diameter, we're going to just go to our thread, right? So we go to our 1/4-20. We'll say okay. Okay, our center drill or spot drill will be the default, okay, number 5, right? Our drill, you can see, is this 201. Even though it's a 3/8, it's still calling this 201, and the reason why it's calling that 201 is from that tap library, right? And then if we get to our tap, you'll see that it's our 1/4-20 tap. All right, guys, that is the Jumpstart Kickstart V6 BobCAM webinar day 1. Covered a lot about job setup here, some of the different tool paths and features. Hopefully you guys have had a good experience. If there's any questions or any additional questions that you guys may have, please let me know. We'll wrap up a few of them. Otherwise, we'll end up seeing you guys tomorrow. Which release of SolidWorks is V6 compatible with? It goes back the last couple of versions, Hugh. I think it's 2011. I will have to check with that. That's a great question, but I think it's 2011 or greater it's going to work with. Any other questions that you guys? Hey, Andy, thank you so much for showing up here today. Brian, I really appreciate you spending some time with us. Hugh, again, I know you guys are busy, so it's really nice that you guys have the time to spend with me. Humberto, always great to see you again. Jerry, John, Justin, Camille made it in. That sounds great. So again, thank you so much for everybody spending a little bit of time with me here. Steven, Ted, Tim, I really do appreciate it. If there's any last questions that you guys may have, please fire them away. I will put together a Q&A document. That's a big reason why I do these, is to build the answers to the questions that you guys have. Hey, not a problem at all. You got some time with that laser, huh? Okay. Is that working out well? I hope it is. Again, I really appreciate everybody spending some time with me here today. I look forward to seeing you guys in the next one. And just so you know, this is a kickoff week. If you guys aren't a V6 customer, you can, they're doing some, because it's SolidWorks World is going on right now, they are having some pretty good promotional deals as far as like licenses, upgrades, extra seats, training, service, add-ons. I mean, anything that you guys want to do with your BobCAM software, this is definitely the week to do it. I don't have the promo phone number. There is a special phone number that you guys need to call in on in order to take advantage of those promotions. Number one, you need to call in on a special number, and number two, you have to tell them that Al told you to call. So you have to say, Al told you to call. So give me just a second. Let me see if I can find the number for you guys before you go, and then let's see what we can do here. Let's see what we can do here. Again, it's always a good thing to help you guys save time. save money, save stress. You know, as always with BobCAD, it's fewer steps, better cuts, and more profit. Don't you love it? I do, absolutely. Again, it's a pleasure spending some time with you guys here. I know you're busy. I know it takes time out of your day to spend some time with us here. Give me just a moment and I'll have this phone number for you. The phone number is 877-333-4903. 877-333-4903. That is the special phone number to call on if you guys want to take advantage of some hot deals with the BobCAM for SolidWorks. Otherwise, guys, we'll see you tomorrow. Thank you so much. Viva la Tampa! All right. Thanks, guys. Bye now.